Hello all, this is the very first problem of the Leetcode, that is to sum. And what the problem says is you are given an array of integers nums and an integer target. Return the indices of the two numbers such that they add up to target, right? You may assume that each input would have exactly one solution, so the one solution is guaranteed for every array input nums, right? And you may not use the same element twice. That is, let's say you have given an array of 2 and you have been provided with a target of 4, so you cannot just say, okay, this is the element 2 and we can use it twice to make the target as 4. So you cannot use the same element twice, although the occurrence of same element in the array is not mentioned anywhere in the constraint. What I meant by that is, you can see the last example, the presence of same element but twice. So that is a different case, but you cannot use the same element twice. Okay, so let's go with the first example. That is, you have been provided with a array of 2, 7, 11 and 15. Let's write down here 2, 7, 11 and 15, and the target is 9. Okay, so you have to find the those two numbers whose sum would be equal to target, and we have to return the index of the two numbers, right? We don't have to return the numbers, instead we have to return the index. Okay, so what could be our approach, right? Here we can clearly see 2 and 7 adds up to 9, right? Let's say for instance our target was 18, so clearly 7 and 11 would be our ideal numbers, right, which will add up to 18. But in order to program it, we have to find the pattern, we have to develop algorithm for that, right? So how should we proceed? As a part of brute force solution, what we can do is, for every element, okay, we should search for any other element, okay, that can add up to target. Okay, so let's say we are currently at 2. We'll see for every other index if that number could add up to target. So what we can do is, currently we are at 2, so we'll check if 7 plus 2 is 9, or that we already got the answer, but let's get rid of this 9. Let's make it the target 18. Okay, to understand it better. So 2 and 7, that is 9. Okay, we'll discard this. The next index is 2, so 2 plus 11 is 13, so we'll discard. 2 plus 15 is 17, almost close, but we want the exact number sum, so even 15 is not acceptable. So there is no complementary number which will add with 2 to get a target of 18. Okay, so we'll discard this whole index. I mean 2 is discarded at all because we cannot pair up anything with 2. Let's come with 7. So currently we are at 7, and for every other indexes we'll find number that can sum up to 18. So 7 plus 11 is 18. In fact, on the first iteration itself, while standing at 7, we got the number. So 7, 11 is accepted. So we have the indexes as 0, 1, 2 and 3. So the answer that we should be returning is 1, 2. Okay, and for this particular case where the example is 2, 7, 11, 15, but the target is 9, the answer would be 0 and 1, right? 2 and 7. But it also says you can return the answer in any order, so either 1, 2 is fine, or 2, 1 is also fine. So in other case, the number 3, 2, 4 target could be 6. I mean target is 6, so clearly we can see 2 and 4. Okay, so 2 is on first index and 4 is on second index, so we are returning 1 and 2. So for 3, 2, 4, right, how we can return? Standing on 3, we'll look for 3 to every other index. So if we can pair up 2 with 3, sum is 5, target is 6, right? Not accepted. So this is not accepted. 3 and 4 is 7, 6, target sum is 6, So again 4 is not accepted, so we'll discard this whole number, right? And for 2 and 4 we are left with just two options. I mean one option, that is 2 plus 4 is 6. And also you'll notice that it is guaranteed that exactly one solution will be existing. I mean there is no possibility that our input contains no two numbers which can add up to target. There is no possibility for that. And there is no possibility for let's say 2 or more pairs that can add up to the target number. So there could not be any array which, let's say 3 3 2 4 and let's say 5, okay, and the target could be 7. So 5 plus 2 is 7 and 3 plus 4 is 7. So there is no possibility that this input array will be provided conditioned with this target sum, okay. So what we are doing is, let's scroll. So what we developed is, let's say our input is 2 11 7 and 15. We'll be iterating through each indexes, and for each index we'll check every other indexes, okay. So ideally we'll be iterating through index of from 0 till n minus 1, right? And for each index, let's say I equals 0 to n minus 1, and for each index we'll be having a j, that is every j I plus 1, that will be going up till n minus 1, okay. And of course this since the answer is guaranteed, will not be going from 0, so will not be going from 0 to last element. In fact, if there is no answer till the third last element, so we'll be only going till second last element, because if we'll go to the last element, there is no other numbers left to pair up, right? So we can only go till n minus 2, and j will go to n minus 1, because j will be iterating to the next number, right? So if you'll see, we are iterating n times for each indexes, which will, I mean not exactly n times, we'll be iterating n minus 1, then n minus 2 and so on, okay. Complexity wise it's a n operation, okay. And for each indexes we are doing this, and there are n minus 1 numbers, I mean iterations, which we'll be doing for this. Again complexity which stands for on. So our overall complexity will be O of n square. But is there a way we can optimize this further, right? So again, so let's write down the input again. We have 2 7 11 and 15, okay, and let's have the target as 18, right? What we can do is, let's say we are standing at 2. So let's say we have a set, right? So we have a set, and we'll say and you know set will not contain the duplicate items, right? So let's say we have a set, and we keep every number, okay, once we encounter that, right? So let's say we encounter 2, okay. So before keeping this number in the set, we'll first check if there is any number which can pair up with 2 to make the target sum of 18 that is present in the set, right? What we are going to do is there any number in the set that can pair up with 2 to make the target sum as 18? And mathematically, if we look down, we are searching for 16, right? So we are searching for target minus nums is the array and whatever the index we are processing, right? So we are processing currently I index of 0, right? So we'll see if we have 18 minus 2 16 in the set. If not, we'll increment the I and store the number. So store the number 2. Now incrementing to 7. Now when we come to 7, what we should do? We should be doing 18 minus current number is 7, so that comes down to 11. Is there any 11 in the set? No. False. Then store the number. So we'll store 7 and we'll iterate further. 11. We'll do the same. 18 minus 11 equals 7. Do we have the 7 in the set? Is it yes? Then okay, true. Then answer is found, right? We have 7 and 11 in the, we have the 7 plus 11 that sums down to 18. Okay, wait, but we have to return index. If you remember, we have to return the index of the two numbers. So in that case, set is not the appropriate data structure that we need to follow. So in that case, it is overruled, and we can omit this, and we can do the same operation with map. Okay, so what we'll do, we'll keep the number, algorithm will remain almost same. So what we are doing, let's iterate again. Let's delete it. I'll delete this one and this one. Okay, fine. Okay, so target is 18. We are currently in the 0th index, that is 2, right? So currently we are in 2, so we are searching for 16. So if we have 16 in the map, okay, as a key, of course, we are going to include the number as the key, and the value will be the index, corresponding index, right? Because we want the index to be returned. So we are finding 16 is not there. So what we'll do, we'll include set in the map 2 as a key and value as the index of it, 0, right? And we'll iterate further. So currently we are at index 1, that is 7. So what we are searching here, false. This key was not there. Now we are looking for 7, that is 11. Again, is 11 in there present in the map? No, so it is false. So what we'll do, we'll include the number 7 as a key and the value as the index of it. The 7 is present in the first index, that will store the value. Now we'll proceed further. We are in the second index. We are searching for 18 minus 11, that is 7. Okay, wait, 7 is there in the map, so it is true. So what we'll do now is, we'll get the current index and the index returned by the map. So we'll search for 7. Let's say map dot get 7. So it will return 1. So our answer will be 2, 1 or 1, 2 is anything is fine, right? So you got the idea, right? What we are doing is, we are iterating through the indexes. We are searching for the complementary number. So basically the complementary number is the number which we can sum up with the current number 2 to get the target number. So mathematically subtracting the number subtract the current number with the target number gives you the complementary number. So 18 minus 2 is 16 is there in the map? No. Then we'll store this number. If the number the complementary number is not found, we'll store this number, because for any other number in the future, this could serve as the complementary number, right? So we'll store the number as a key and the index as the value, right? So we'll iterate further. So we are in the 7. So 7, complementary number for the 7 is 11. Is there any 11 in the map? No. Then what we'll do, we'll store 7 as a key and its index, that is 1, as a value. We'll iterate for the other, we'll iterate further, that is index number 2. We'll find 18 minus 11, that is 7. 7 is present in the map, and that's when we got to see the complementary numbers, the two numbers that can add up to 18. And the answer will be the current index that we are standing and the index returned by the complementary number 7, that is 1. So 1, 2, 2, 1 is anything is fine. So we are iterating just once and storing the number in map, and the set get operations are of O1. So for every number at max we will be doing this get or set operations for each operation, so that is O of 1. So overall the complexity becomes O of n from O of n square. So let's see how we can write the equivalent JavaScript code for this approach. So let's have this constant map where we'll be storing the number key value pair for this number and indexes, right? So we'll have new map. So map object will be creating. So and we'll be iterating through each number. So let index be 0, index is less than nums dot length, and index plus plus, right? Let's call the complementary number as diff, right? Diff, which is target minus current number, that is nums index, right? Okay, so what was the first case? If we don't have that difference, that is the complementary number. So if map does not has the diff, what we are going to do, map dot set. So what we are storing, the key value pair, where key is the number, current number, that is nums of index, right? And the index of it, right? Now what if the difference exists, that is complementary number exist? In that case we have to return an array of indexes of both those number. So the current number is index, I mean for the current number the difference is found, that's when it will come to else block. So this index and the complementary numbers index, that is the index of the diff. So map dot get of which number, the diff, that is complementary number. So this would be our answer. So let's run it and see. So yes, you can see we have this 2 7 11 15, the answer is 1 0. Okay, see, the Leetcode was expecting the answers to be 0 1, and it says you can return the answer in any order, right? So we can return the answer in any order, that's fine, and that's how we can submit this solution. So let's submit it and let's see. Okay, yeah, so it is accepted and all the test cases passed. Thank you for watching till here, and let's meet in the next problem. Thank you.